Hi students, in this video I am going to continue with the sensitivity analysis. In order to uh, perform sensitivity analysis, what you need to do is first uh, prepare the cash flow statement using the most likely values of the key cash flow variables. um, as you see here, or as explained in the previous video, and then you have to calculate the net present worth as shown here for this uh, cash flow. Then after that you have to prepare a table like this. Okay, where you have the key variables on this side here and the percentage variation of each of the key variables is shown on the top row here, and the net present worth for the most likely estimate is when the percentage variation is 0. So when the unit price percentage variation is 0, while all other variables are held constant, then the net present worth is equal to 11,107. So at 0% variation, the net present worth will all be same, which is 11,107. So in all this, it will be 11,107. So now for each of these variables and each of the variations above or below the uh, initial value of the net present worth, you have to calculate the net present worth. Like for example, if you vary the unit price by minus 5% or decrease by 5% over the initial unit price, which was 80,000. So if you decrease the unit price by 5%, from 80,000, but keep all other variables same without changing. Keep all other variables fixed without changing, but only change the unit price, which is 80,000 by decrease the unit price, which is 80,000 by 5%. So when you do that, when you decrease the unit price of 80,000 by 5%, then the unit price here will be changed. So 80,000 minus 5% of 80,000. So when you change this, then the sales revenue will also change accordingly, because sales revenue is the demand 1,500 into the decreased unit price, which is decreased by 5%. So all this sales revenue will change, while all other variables will remain constant. And because of this, the net income will change and income taxes will change and net income will also change. So following the similar method or procedure, calculate the new, you will get a new cash flow, and then calculate the new present worth for the new cash flow that you generated with the unit price decreased by 5%, and that net present worth you bring it here, you copy it here. And similarly for all other percentage variation of the unit price, you calculate the net present worth for each of them. Similarly for demand, you increase or decrease by certain percentage, for example -5 or +5, and then for each variation you calculate the net present worth, similar to what you did for unit price. And for all other variables you calculate, and whatever values you get here, then you plot on a graph, and you will get a graph something like this. And when you calculate for each percentage variation of each of these key input variables, you get the net present worths as shown in the bold numbers. So these values of the net present worth you plot on a graph, and it will appear something like this, from which you can see that this blue line and purple line has more effect on the net present worth. So this blue line is the unit price and the purple line is this variable cost. So you can see that the net present worth of a project is more sensitive to unit price, change in unit price and variable cost. So from this you can estimate as to you can actually see the extent of the effect of each variable. You can actually approximate or estimate the effect of each of the variables on the net present worth of a given project, and accordingly plan for the project and prepare for the unforeseen situation, or maybe then you can think of some of the mitigation plan for mitigating the risk. Okay, so now to proceed further, let us look at the scenario analysis. Before we go into the scenario analysis, let us see the limitations of sensitivity analysis. The limitation of sensitivity analysis is that it is difficult to specify the relationship between a particular variable and net present worth. Why it is so is because we are relating the net change in net present worth by changing only one of the variables by a certain percentage, keeping all other variables fixed or constant. In the practical or real situation, that would not happen. The thing is that all of these variables will actually may actually simultaneously change. So with sensitivity analysis, what we are assuming is that only one of the variables will change by certain amount, and with that assumption we have calculated net present worth. But in reality, that may happen very rarely. and in most cases all the key variables might change simultaneously. So for such situation, if such situations really happen, then the analysis uh, made using sensitivity analysis or sensitivity method will not hold good, and it will not provide us confidence in making decision about the investment. uh, uh, the other thing is that the relationship between uh, the between the net present worth and the key variables could happen because of the interdependencies among the variables. By this, what I mean is that the effect of the key variables on the net present worth may not be uh, independently independently each variable affecting net present worth independently. Uh, the net present worth might be affected by uh, the interdependencies of various uh, key variables. Uh, if I explain further, in the sensitivity analysis, what we did was that we calculated net present worth by varying each of the variables by certain percentage while holding all other variables constant. That is equivalent to assuming that each variable is affecting the net present worth independently of all other variables on the net present worth. But in reality, the effect on the net present worth could be because of the interdependencies between unit price and demand, which actually is so in many cases for many people. Like if the unit price is increased, then demand will decrease. So they are not independent, they are related. And this dependency between unit price and demand might be affecting the change in net present worth, not unit price and demand independently. So similarly, growth rate and unit price may be related they might be dependent upon each other, or maybe uh, all of them may be dependent on each other in a complex uh, way, which is, by the way, very difficult to uh, uh, describe. And that affect and the interdependencies among all the input variables combined might be affecting the net present worth. So these issues are not taken care by sensitivity analysis. So in order to take care of these issues, scenario analysis is used. So in case of scenario analysis, sensitivity of net present worth to changes in both the key variables and the range of likely variable values are uh, used. So that way we are taking care of the changes in the key variables and the dependencies amongst the key variables. So in case of scenario analysis, uh, we can consider two extreme cases, namely worst case scenario and best case scenario. So when we, for example, take worst case scenario, then we are changing the values of likely values of the key variables simultaneously. Unlike in the case of sensitivity analysis, we are actually changing the likely values of key variables simultaneously. If you see uh, here and compare with the sensitivity analysis, the values taken for each key variables for sensitivity analysis and variables likely values of the key variables for scenario analysis. So if you see here, you can see that in case of sensitivity analysis, when we take low values of each of these variables, then we are taking low values for all these variables. That is as if keeping all of them constant without variation. Low values for all of these key variables means not changing the values uh, of the variables simultaneously. Whereas in case of the scenario analysis, when we take worst case scenario, uh, we are changing the key variables, the values of key variables, uh, assuming that we are assuming that the values of the key variables are not taking on low values in all for all the variables. So in the worst case, market size is minimum, for example 1000, when compared to the best scenario where you have greater market size. But when we talk about the unit variables, in the worst case, it is worst case. When we talk about worst case, it should be highest. In the best case, it should be lowest. So it is just the opposite. You can see in case of sensitivity analysis, the unit variable cost is lowest, and for all the for all the key variables it is the lowest values. But in case of scenario analysis, when we say worst case and best case, then we are simultaneously changing. It is not like for all the key variables the values are lowest. So now you can see that the unit variable cost is highest in this case, so which is different from the lowest value as you saw in the sensitivity analysis. Similarly, in the worst case, the fixed cost is highest. So here we have changed the values of each key variable simultaneously. Instead of keeping all of them low, we have changed where some key variables are kept low while others are increased. Okay, like for example, market size is kept low, market growth rate is kept low, but unit price is increased. Oh no, unit variable cost is increased, fixed cost is increased, salvage value is decreased. So you can see for one set of situation we have different values of each of these variables. For some it is low, for some it is high. So that actually means that we have simultaneously changed. Whereas in case of sensitivity analysis, all the values were assumed to be low compared to this situation. Okay, so using this uh, probable values of each of these key variables, we then generate the cash flow as we did for the sensitivity analysis using the most likely values of each of these variables. So in case of the scenario analysis, the cash flow for most likely scenario will be same, so that will not be done. We will use the same cash flow, whereas for worst case scenario and best case scenario we will generate cash flows and also calculate the net present worth for each of these extreme scenarios. So as before, you can proceed. You can actually put the values of each of these key variables for worst case scenario in this column, and then proceed with the income statement and generate net income using these values, and then generate the net cash flow, and from that you calculate the net present worth, which gives minus 42,755. Similarly, for best case scenario, you change the values of each of these key variables using this, then you generate cash flow again in the similar manner, and then calculate the net present worth, which gives 87,231. So from the scenario analysis we can see that the base case produces positive net cash flow, net present worth of 11,000, which you saw in the earlier slides. And in case of the worst case scenario, it actually generates negative cash flow, negative present worth of minus 42,755. And when we took the best case scenario, it generated a positive cash flow of 87,231. So if you see here, we have a range of net present worth starting from minus 42,755 to positive plus 87,231 with a mean of 11,107. But what do you get from this? Still, these results actually do not provide enough information to make decisions. Yeah, we can see that in the worst case scenario, the net present worth will be minus 42,000, and in the best case scenario it will be positive 87,231. But this figure, this type of figures we can also generate with uh, sensitivity analysis. Actually, it doesn't provide any additional information relative to the sensitivity analysis. What if somebody says that there is a chance of losing the money on the project? Or what if somebody asks this minus 42,755 is not possible? So when we say not possible, then we are talking about probability. So if somebody says not possible, then the probability is that means the probability of minus 42,755 neutron net present worth is 0. But is he really correct? So no, with scenario analysis actually we can actually find out the probability of each of them actually. Okay, so that means we need to estimate the probability of occurrence of the worst case, best case, and base case, or maybe all other possibilities. So in that case, we can use this scenario analysis. From this argument, we can see that there is a need to estimate probabilities, and for that we need to develop a probability distribution function. And to do that, there are two fundamental approaches. One is to consider the risk element directly through probabilistic assessment of the cash flows, or adjust the discount rate, that means adjust the MARR to reflect the perceived risk in the project's cash flow. So this second one we will not do, we will actually look at only the first one. Okay, so now in order to actually consider the risk element directly through probabilistic assessment, a common method is to use again three estimates of each year's cash flow. Like in the case of PERT, where you estimated, you made 3 time estimates for each activity. Here, for each cash flow, for each year's cash flow, 3 estimates are prepared. One is optimistic estimate, assuming that everything will go well. That is the best case scenario, assuming the best case scenario. Another is pessimistic estimate, where you assume that if everything goes as poorly as reasonably possible, then we are actually talking about worst case scenario. And most likely estimate, which is actually talking about most likely scenario. So like in the case of PERT network, here also beta distribution is used, and using the optimistic, pessimistic, and most likely estimate of each year's cash flow, we can actually calculate expected cash flow for each year. Expected cash flow in period n equal to H plus 4 ml plus L whole thing divided by 6. Actually, this expected cash flow in the period n is also nothing but a mean. Then for each cash flow, we can calculate variance cash flow for the period n. The variance of cash flow in the period n is given by H minus L divided by 6 whole square. So, using the annual cash flow estimates in the scenario analysis as 3-point estimates for each period, we can compute the mean or expected cash flow and variance of the net present worth distribution. Okay, so what we do is we actually transfer the cash flows from the worst case scenario and put it like this in this form of the table. So this cash flow for year 0, year 1, year 2, year 3, year 4, year 5, all of these are brought from the cash flow generated using worst case scenario. here. You can see here. So what we have done is we have transferred this cash flow here in the worst case scenario column. Similarly, the cash flow from generated using the most likely scenario that was generated in the earlier slides is transferred here, and the cash flows generated from the best case scenario that was generated here, this cash flow is transferred here. So these three cash flows for example, for year 1, the optimistic estimate is then 35,244. Pessimistic estimate is 1,944, and most likely is 16,344. So using these three estimates, then we can calculate the expected cash flow for each of these years, and also we can calculate the variances for each of these years expected cash flow. So which you can see here using this formula you calculate the expected or mean cash flow for each period. Similarly, using this formula for the variance, which was derived using beta probability distribution function, you calculate the variances of this expected cash flow for each of the periods. And these present worth are calculated using the cash flow, respective cash flow for the respective scenarios. As you saw in the earlier slide, actually, where was it? Here. Okay. The thing is that for best case and worst case, you can calculate the present worth, as you saw in the previous slide, and this is what is shown here. Now we can then find out using these expected cash flows for each year, we can calculate the expected present worth. Okay, the expected present worth, which is denoted by EPW 15%. So this is different from this, which is only present worth at MARR of 15%. Here it is expected. So that means we are trying to find out the mean net present worth. of the expected cash flows over the project's life. Okay, so to find that, we use this formula: expected present worth at given MARR. Okay, but this R in this equation is risk-free discount rate. So in the calculation of this MARR, the risk is not considered. Okay, the risk component is not included in the calculation of this MARR. The risk is actually aggregated. The risk in this project is actually aggregated using this relation H plus 4M plus L holding divided by 6. Okay, using the beta probability distribution function, the risk is aggregated. Each year's risk is aggregated using the beta probability distribution function. Okay, but the thing is that each year's cash flow is independent of the other. The cash flow of year 1 has no effect on cash flow of year 2, so they are considered to be independent. Each year's cash flow, expected cash flow, is considered to be independent from each other. But for each year's cash flow, we have considered a range from worst case to best case. But within the particular year, the variability is taken care using the net beta probability distribution function. So when you calculate the expected net present worth using this equation, it gives mean net present worth where the cash flow is assumed to be independent. Each year's cash flow is independent of other. So you can see here actually from the formula what you have done is expected cash flow of particular period n divided by 1 plus r raised to n. So this equation is essentially nothing but the present value of this expected cash flow. So the expected or mean present worth is calculated by just summing up the present value of each year's cash flow. Since this is just a summation of the present value of each year's cash flow taken to the present time, this means that we are assuming this means that the each year's cash flow are independent of the other cash flows. Or in other words, when we calculate the expected present worth of this cash flow, we are assuming that each year's cash flow is independent of the other. Okay, so we can also find out the variance of this expected cash flows using this formula, where VAN is the variance of period n divided by 1 plus r whole raised to 2n, and n is nothing but the period. So using these two equations we can get these values, and from this we can find out the probability. So the probability of the present worth being less than or equal to 0 we can get using this formula. Z is equal to x minus mu, which is the mean, divided by whole thing divided by the standard deviation. The standard deviation is nothing but under root of the variance. Okay, after you calculate the variance using this formula, then you take the square root of this, the value that you get here, and then you get the standard deviation. Okay, so what is the probability of given present worth x? So that is what we are trying to find out. So using this formula we can find out the probability of this expected present worth. So the probability of the expected present worth being equal to 0 minus the mean, which is 14,817 that we calculated here, that means what is the probability of the cash flow equal to 0? What is the probability that the net present worth will take on, net present worth x will take on that will be equal to 0. So 0 minus the mean expected present worth divided by the variance standard deviation of the expected present worth. So that will give you minus 1.5253. So from the normal probability table, we can find out the value of probability using this 1.53. So 1.5, you can look along this column. You can see 1.5 here, and this 0.03, this 1.53 is nothing but 1.5 plus 0.03. So this 0.03 we can look up along this first row. 0.03 is here, so we go down wherever this 1.5 and 0.03 meet, that will give the value of the probability, which is 0.9370. Since the z value is negative here, that means this 0.9370 indicates the probability of the net present worth greater than 0, not less than 0. So that is why the net present worth the probability of net present worth being less than 0, to find that we have to subtract 0.9370 from 1. So that will give the probability. So the probability of the net present worth being less than 0 is equal to 6.3%, as you can see here in this figure. So the probability of net present worth being less than equal to 0 is 6.36%, which is the area of this area under this curve from here to here. So the probability is from here, this side. So if you calculate the area under this curve from this point, this side, on the left hand towards the left side, then that will give you 6.36%. The 0.9370 is the area on this side of the normal probability curve, area on this side. Okay, so I think I will stop here because the video might have become very long now.